So today we're going to look at exponential and logarithmic functions. And an exponential function is in the form of y equals a b to the x. And there are a couple of restrictions. The first one is a can't be equal to 0. Because if a equals 0, then it cancels everything out. And b needs to be greater than 0, but b cannot be 1 because 1 to any number is still 1. So we lose the exponential. But where we're really going to spend our time today is graphing. And this first graph might look familiar from Algebra 2 days. And what we can do is we can calculate these values by hand, but we can also type them into our calculator and fill in the chart, whichever way works for you. So we can go to y equals and we can type in 2 to the x. I'm going to look at the table. And here, my actual numbers that I used were 2 to the negative 4th. I used 1/16. It doesn't make any difference to me whether you use the decimals or you use the numbers here. But 2 to the negative 4th is 1/16, which is the same thing as 0.0625. So if you like 0.0625, put that in there. And 2 to the negative 3rd, we flip and change the sign of the exponent. So it's 1 over 2 cubed, which is 1/8, which has a decimal of 0.125. And 2 to the negative 2nd is 1 over 2 squared. We flip and change the sign of the exponent, which is 1/4, which is 0.25. And we continue this pattern here. 2 to the negative 1 is 1/2. And 2 to the 0 is 1. And 2 to the first is 2. And 2 squared is 4. And 2 cubed is 8. Reading off your table or filling it in. You don't even have to do that. And what we want to do is we want to graph. And it's -4, 1/16. And -3, 1/8. And -2 is 1/4. -1 is 1/2. And 0 is 1. And 1 is 2. And 2 is 4. And 3 is 8. You may remember from your Algebra 2 days that this is a non-linear function. And it looks something like this. And we can get some information from our picture, like our y-intercept, a horizontal asymptote, our domain and range. Easiest value here is y-intercept. What's the ordered pair for the y-intercept? 0, 1. We do have a horizontal asymptote. Do you have any idea what it might be? And we're close here. It's y equals 0. Our domain on this problem, typically what happens, if we can pick negative numbers and we can pick positive numbers and we can pick 0, our domain is all reals. But if you did the last Math Excel assignment, you might have been able to come up with the fact that the range and the horizontal asymptote are linked. And in this case, what happens here is that our blue part of the graph, and I did the best I could here, never touches that purplish colored line, nor does it go below, which means that all of our range is going to be from 0 to infinity is going to be above that line. 0 is not part of that. So now let's put a little spin on it. We've got 2 to the negative x minus 2. We've got a couple transformations. What's the easy transformation in this one? You probably know that it's down 2. But do you remember that a negative as the exponent, it reflects? Is it reflected over the x or the y? It reflects it over the y. And the nice part is, if you didn't know that, we could type this into our calculator, and we could look at the picture here, and we would be able to tell that. At least I think we would. 2 to the negative x minus 2. And there's our picture. Now, I didn't put a table on this one, but we do know a couple things. But what I want to point out is when I turn this one back on, here's the first graph that we graphed. It's going to be in blue. Notice that we went down 2, but we went down 2 from our y-intercept. Down 1, 2. So our y-intercept was at 0, 1, then 0, 0, then 0, negative 1. There's the down 2 concept. If we look at our table, we can draw a picture, and then maybe we can come up with some of our other values. And I do want to go back and turn off that first one, so we can look at the table a little bit easier. And then I'm going to do one more thing, which is I'm going to start at 0. So here's a couple of values, and I do want to go into the negatives a little bit. But we've got negative 4, 14. Negative 4, 14 will fit on our graph. And negative 3, 6. And negative 2, 2. And negative 1, 0. And 0, negative 1. And 1, negative 1.5. 2, negative 1.75. 3, negative 1.875. 4, negative 1.9. But in general, we've even seen the picture already. We get the idea. And there's our rough picture of that, of 2 to the negative x minus 2. And what we want to come up with again here are the y-intercept. Where does our graph cross the y-axis? And I just deleted the table, but we can see that it crosses at 0, negative 1. Do we have a horizontal asymptote in this one? And we actually do. I heard it. It's y equals negative 2. You could even see it a little bit in our table. And I didn't do every single value, but 4 was negative 1.9. And I don't remember what 5 was. But we're getting closer and closer and closer to 2. And there's this relationship between the horizontal asymptote and the range. And that is that it's going to be negative 2 to infinity. Our graph is every value above that purplish line. And then the question becomes, is our domain on this one still all reals? And it is. And it's nice to be able to have the calculator to help us with it. But this gets us into the graphing a little bit. And now let's look at an old favorite that may or may not be. Let's graph the inverse of 2 to the x. So remember, when we're graphing the inverse of 2 to the x and the y values switch. So if you wrote yours in decimal, then you're going to have decimals on yours. I wrote mine in fractions. But down here, then, this is -4, -3, -2, -1, 0, 1, 2, 3. Our x and y values switch. That's the whole idea behind inverse. So for me, 1/16, 1/8, 1/4, 1/2, 1, 2, 4, 8. Copying the table down from our first example, just switching the x and the y values. And why don't we graph it? We're going to have to graph them both here in a couple minutes, but why don't we graph it right now? And what it is it's 1/16 -4. And 1/8 -3. And 1/4 -2. And 1/2 is -1. 1, 0. 2, 1. 4, 2. 8, 3. And there's our picture. And what we just graphed is we graphed, or the inverse of an exponential function. Sorry, I reversed the T and the I and I'm just now seeing it. It's called a logarithm. And the equation for this particular inverse would be y equals log base 2 of x. And if you think back to our whole unit that centered a lot around inverses, when we're talking about inverses, what happens is not only do we switch the x and y values, but the domain and the range switch. So if we go back to this first problem here, and we look at our domain of -infinity to infinity, that's going to be the range of our graph that we just graphed. It's going to be -infinity to infinity. If we go back to our first graph, which you can see on your paper, you don't have to flip screens here, but our range of our first graph is 0 to infinity, which means that our domain of our function, of our inverse, is 0 to infinity. Because not only do the x and y values switch, but so do the domain and the range. That makes it a little bit easier, possibly, to find those values. But what's the intercepts? What's the, well, the x-intercept of this graph? Because do we have a y? We're never going to touch the y-axis because our domain goes from the y-axis to the right, but we never quite touch the y-axis. So we don't have a y-axis. Sorry, we don't have a y-intercept. We have an x-intercept, and that is our 1, 0. In this particular graph, we do have an asymptote. And if you think about it, once again, back here on problem number 2, our asymptote was y equals 0. We've switched everything else, and that's what's going to happen here as well. We're going to have Need another color. X equals 0. Remember, inverses reflect over that line that goes from corner to corner. Lower left-hand corner to upper right-hand corner. And that line is the equation y equals x. And let's put in now our original graph, because what it lastly says, it says draw this graph along with f of x equals 2 to the x. So we already drew it, but our graph of f of x equals 2 to the x is the same one that we had above here, which was the 1/16, sorry, the -4 1/16, and the -3 1/8, and the -2 1/4, and the -1 is 1/2, and then we have 0 1, 1 2, 2 4, and 3 8. And as you draw this in, taking a look at this, if we fold this graph along that green line, will the black graph land on the red graph? And sure enough it will, which is one of the ways that we can at least visually check to see that these are inverses.